So in this section, we are going to look at equations that have fractions in them. I'm going to go through two examples. In the first one, I'm going to show you what could be done and what should be done. So we're going to have two solutions for the first example. One that's going to give us the right answer, but with more work, and one that's a bit more efficient. And I want you to see both solutions because well, they're both valid, but maybe you'd appreciate the one that's more efficient if you see the one that takes a bit more work. So solution one is not the one I would recommend, and it's not the one you'll find in the book. In the book, they have they have the efficient solution. So if I start, I'm just going to recopy the problem. So one thing we could do is try to just say, okay, I want to have only x on the left-hand side, and I'm going to start by removing this. So I'm going to add, right, in our head. So I'm writing this, but you don't need to when you write down your solutions. We're going to add 7/2 on both sides. So if I add 7/2 to minus 7/2, it becomes 0. So I just get 3/4 of x on the left hand side, and on the other side I get 5/6 plus 7/2. Now 5/6 plus 7/2, eventually whatever I do, I'm going to have to add this up to figure out what this is. So this is where I need to do a bit of work in order to figure out what goes on the right hand side. So I need to find a common denominator for my fractions. So remember what you do, you pick the largest one, 6, and you look at the multiples of 6 and you try to see, can I fit the other number into it? So you start with 6, can you fit 2 into 6? Yes. So that's your the common denominator you're looking for. So I'm going to put everything over 6. To do this, we need to multiply by 3 above and below here. So 21 over 6. So this is 3/4 of x equals to 26 over 6. 26 over 6, I can reduce that fraction. So 3/4 of x is 13 over 3. Oh, maybe something to point out. Notice I'm not putting equality signs here. It's because equations are not equal to each other. In fact, we say they're equivalent. Like, so what I have are equivalent. This is a symbol for equivalent between equations. Okay, it also means if and only if, but here I guess the right word for it is equivalent. So I'm not going to force you to put that symbol, but don't put an equality sign, that's for sure, because you don't want to have equality signs between your equations. Okay, so I've got 3/4 is 13 over 3. I've reduced my fraction on the right hand side. Now I'm going to get rid of the 3/4. So what do I do to get rid of 3/4? You multiply by the reciprocal, 4/3. So that means x is going to be 4/3 times 13/3. So that's 4 times 13, 52 over 3 times 3, 9. And that's our final answer. Solution 2, I hope you'll appreciate how nice it is. What we'll do is, before doing anything with our fractions, we're going to put them all over a common denominator, and then we're going to do what's called clearing the fraction. Okay, so this is what the book calls clear the fractions first. Get rid of them. So that's what we can work with, just integers. So with this technique, we're going to look at all the denominators, and we're going to find a common denominator for all fractions. So once again, you take the largest denominator, 6, and you look at its multiples, and you try to find the smallest one in which you can fit the other two denominators, 4 and 2. So can I fit 2 into 6? Yes, but I can't fit 4 into 6. So I'm going to look at the next one, 12. Can I fit 2 into 12? Yes. Can I fit 4 into 12? Yes. So that's the one I'm going to pick. So that's my common denominator. So I need to multiply to get 12 here, multiply by 3, right? So 3 times 3, 9. Here I need to multiply by 6, minus 42 over 12. And here multiply by 2 above and below. That's 10 over 12. And I'm missing an x somewhere. Yes. Okay. And once I have this, okay, it's just the same as saying it's 9x minus 42 over 12 equals to 10 over 12. And everything's over 12, so what I can do is clear those denominators. Why can I do that? It's because I can get rid of them by multiplying by 12 on each side. And if I do this, they go away. So I'm just left with 9x minus 42 equals to 10. Okay? So I'm just left with the top part here. So I wrote this down so that you understand what was happening, but this is not a step you're forced to write down. You can just go jump from here to here. And now I'm working with integers, which makes things a lot easier to work with. So I add 42 on both sides to get rid of minus 42, get 52. I divide by 9 on both sides, and finally I get that x is 52 over 9. So I'll just show you what your solution should look like when you become good at this. Usually we don't put those. Okay, there's going to be an x though. We don't put the times 6, so I'm not going to put all these little details. I wouldn't write this down. I wouldn't write this down, and I wouldn't write this down here. So that would be my solution here. Just those steps. Okay, it's clean and clear. Okay, so let's look at another problem. We're going to solve 1/3 of n, we're going to solve for n, plus 29 over 6 is equal to 2 times 4/3 of n plus 2/3. Okay, so I've got n on both sides here, right? It's here and here. Eventually I'm going to have to send it all on the same side. So I've got this bracket that's in the way on the right hand side. I'm going to expand everything on that side. 2 times 4 is not 6, it's 8/3 of n plus 4/3. And here I'm not changing anything here. After that, I'm looking at my denominators. I'm looking for the smallest common denominator, and that's going to be 6, right? I can fit all of those into 3 and 6 can be fitted into 6, so I'm going to have 2n plus 29 over 6 equals to, I need to multiply by 2 everywhere, so that's 16n plus 8 over 6. I multiply by 6 on both sides. And now I'm going to regroup those two terms that have n in them on the same side. I like to work with positive coefficients, so I'm going to send the 2n on the other side, right? So subtracting 2n is like sending this on this side, so I get 16n minus 2n, so that's 14n, right? Plus 8. I'm going to send the 8 on the other side. You can actually do that at the same time. So if I send in on the other side, I subtract 8, I get 21. Here we go. So n is going to be 21 over 14. I actually kind of like to put my n first. 21 over 14. I recognize these are two powers, multiples of 7. So this is, 3/2. So n is 3/2 is our answer. Of course, I could check by replacing n in the above equation, and just to see that it works out. That's it.